Hi everybody, my name is Ella Moore, and today I'm going to be conducting an experiment on the effects that sodium bicarbonate has on alkalinity. This at-home experiment was done for exam 2 of Engineering 351, or Introduction to Water Quality. So the question I'm going to be trying to answer today is, how does alkalinity affect changes in pH? In order to answer that question, we're first going to look at the definition of alkalinity and alkalinity with respect to sodium bicarbonate and pH. Alkalinity is the ability of a water to take on acidity or a base with minimal decrease in pH. It's also considered a measure of buffering capacity. And so you may be asking yourself, what is buffering capacity? As you can see on the graph right here, we have a graph of pH versus volume of strong base. This also works for volume of strong acid. The graph would just be in a different direction, the opposite direction. And right here we see the buffering region, which is what the buffering capacity is referring to. And so pretty much what adding a buffer does is, the more strong base you add, there will be gradual increases in pH decreases in pH increases in pH, up to a certain point, and then the pH will buffer and kind of plateau, and then past another certain point, it will go up on a steep decline. So here is my equation list. We have A, B, C, and alkalinity is calculated using equation A, which is this one, where concentrations are calculated in units of normality. So you can see baking soda, or HCO3, which is sodium bicarbonate, or bicarbonate, excuse me, is right here, and so it contributes to alkalinity, but alkalinity is measured in MEQ over liters, and in order to find that, you need these two equations, which find normality and equivalent weight. So taking a closer look at this alkalinity equation, as I said before, we can see that one of the ions that contributes to alkalinity is HCO3, also known as bicarbonate. And bicarbonate is present in abundance in the household product sodium bicarbonate, which is also known as baking soda, which is really convenient for us because it means that we have a very on-hand chemical that we can use to experiment with alkalinity. So our hypothesis that we will be working with today is that the addition of baking soda to a solution will increase the buffering capacity, which is what we talked about with the graph of the buffering capacity. All right, so I created an experimental setup using 2 mason jars, pH strips, alkalinity strips, a pH meter, vinegar, baking soda. And so pretty much how I plan on testing the alkalinity with respect to baking soda is, I will fill 2 mason jars with 12 ounces of warm water. I decided warm water because I think it would make it easier for the baking soda to dissolve into. And then I'm going to add 1 tablespoon, which is 14.4 grams of baking soda, to one of the water samples, and then I'll just stir it until it is dissolved. Then I'm going to measure the initial pH and alkalinity of both samples using the alkalinity strips and the pH meter. And then I'm going to add apple cider vinegar to both of the solutions, 3 drops at a time, 10 times. And between each set of 3 drops, I'm going to measure the pH of both solutions and record that. And then after my 10 times of adding 3 drops, I'm going to add spoonfuls of baking soda until the buffering point is reached. I decided to add this spoonful method at the end because I'm worried that it is not going to reach the buffering. It's not going to reach the buffering capacity with the little amount of vinegar I will be adding. So I'm going to kind of employ a fast and dirty method where I'm just going to add it kind of unscientifically at the end to see if it isn't reached, if I can reach it. All right, so that being said, let's go ahead and try out our experiment. This water is warm, so hopefully it will dissolve. Both solutions are warm.
And I guess I'm going to stir it now with the spoon that I have, just to make sure everything looks pretty dissolved. Yeah, okay. So here is the alkalinity test strip, and we're going to dip it into this water, swirl around twice, and then immediately read the alkalinity measurement. So 1, 2, and then I'm gonna take it out, and it looks like, it says it's like maybe 240. It's very blue. So yeah, I think 240. So now we're going to test the alkalinity of the non-sodium bicarbonate solution. So we're going to dip it in, swirl twice. 1, 2. And as you can see, this alkalinity looks a lot less alkaline. So I would say it's either 80 or 120. So now we're going to measure the initial pH of the solution with the sodium bicarbonate in it. So we're going to stick this in. We're going to wait probably 20 seconds. Now we're going to put 3 drops of our apple cider vinegar into both of our solutions. So 1, 2, 3. All right, and we're going to put it in here. 1, 2, 3.
Alright, so I just got back from doing my experiment. I've thrown all of my raw data into this table right here. As you can see, I have my volume of acid, which is represented in units of drop. So I just was counting the drops. And then here in this column, we have the pH of the control solution, which had an alkalinity of 80 ppm. In this column, we have the pH of the alkaline solution, which had an alkalinity of 240 ppm. Both of these were measured with the strips, as you saw in the video. Additionally, I calculated that 173 drops were in a spoonful, which is how I calculated the amount of drops after I started adding spoonfuls. And I just did this by filling up a spoon with drops or the spoon I was using with drops until it was full. Some observations that I saw was the color of the alkaline solution was much darker yellow. This can be seen in this slide right here. This is the alkaline solution. As you can see, it's much, much darker than the non-alkaline solution, which just was vinegar and water. And then the alkaline solution tasted and smelled a lot more metallic and not necessarily acidic. I didn't drink the alkaline solution, I just tasted it. All of the things that I was using were food safe. They were things that I had in my kitchen already. And the control solution tasted acidic. It just tasted like basic lemon water. So yeah, it was metallic and acidic. Okay, so here we have our graph of the data that we had in our table right here. As you can see, it is the effect of alkalinity on pH buffer. On the x-axis, we have drops of vinegar, and on the y-axis, we have pH. And so the blue line represents the control solution, which had an alkalinity of 80 ppm. And as you can see, there was a very steep decline in pH, so it became acidic very quickly in the beginning. And then it looks like it leveled out after like about 500 drops of apple cider vinegar. Which is very interesting. The alkaline solution never got to the same pH of the control solution, which makes me think that it never really reached its buffer point. as you can see also, it was a lot less acidic than the control solution for the entire experiment, which means that bicarbonate is a very effective buffer for acidity. As you can see, the decline was kind of steep in this area, and then it looks like it plateaued a little bit right here. I don't really believe that that was the buffer point. It just kind of looks like it plateaued. I'm not sure why. And then it was steep right here. The reason that I don't think that it buffered here is because the change in pH after the plateau here was not like steep enough to make me think that it had reached the buffer point. But those are just my interpretations of the results. For reference, here is the pH versus volume of strong base. So the volume of strong acid would be in this direction. It would kind of be the opposite of that. But the buffer looks very clear. The buffering region is very clear in this graph, while the buffering region is not as clear, or maybe not even present in this graph. So it leads me to believe, finally, my conclusion, I believe that the buffering point was not reached, probably because I added way too much baking soda, and I think that the solution was just too strong of alkalinity for it to be able to reach with the level of acidity that I was adding. Thank you so much for listening to my video, and let me know if you have any questions. Thank you so much.